right, welcome to today's session. So this is our lesson for Unit 4, Session 15. So we have been talking about ratios, and we're moving from ratios into rates at this point. So these first two lessons on rates are just going to be kind of exploring and understanding what our concept of rate and unit rate is. Okay, so here's our standard number and then our wording for our standard. Understand the concept of a unit rate, A over B. So you associate that with a ratio. All right, associated with a ratio A to B. So if you're given a ratio A to B, you should be able to write that as a rate of A over B as a fraction. Okay, with B not being zero. All right, use rate language in the context of a ratio relationship. So we're still talking about ratios, and we're going to use those ratios and apply them to a rate. So for this first problem here, it says teams of students in Miss Sada's class make robots. The red team's robot travels 6 feet every 3 seconds. The model shows the ratio 6 to 3. Complete the model to show the equivalent ratio that tells how far the red team's robot travels in 1 second. Okay. A lot of information there, right? So we have a ratio. Now, your curriculum has you set this up on a double number line. Double number lines are great. They're a great strategy. You want to use them? Use them. Amazing. All right. But I have noticed that using those tables of equivalent ratios can be a repeated strategy. It's already a suggested strategy for some lessons, but it can be repeated for most of what we're doing. Comparing ratios, equivalent ratios, okay? So when we're finding a rate, we are finding equivalent ratios, okay? So our ratio that we're given is 6 to 3, right? We can write that as a fraction, 6 over 3, right? That's our rate. 6 feet every 3 seconds. So when we add those units to it, we've got our rate, all right? And we want to change this and find equivalent, something equivalent, so that we want to know how far the red team's robot travels in 1 second. So we want 1 second on the bottom here, right? So we can think of them as fractions. That's fine, right? I really do like a repeated strategy that can be used for things. I think it's helpful to see the connections there. So fractions are similar to your double number lines. All right, you've got your 6 over 3 here on your double number line. That's your ratio, 6 to 3. If we remember before what we did with double number lines, we said, okay, we're making equivalent ratios here, right? So 0 to 3, that's 1, 2, 3 marks from the 0. So this is 1, 2, and then that gives me 3. Same thing up here. I have 3 marks, and I get to 6, which means 6 divided by 3 is 2. So this is 2, 4, and then we have our 6. Now, I get why the curriculum does this, because now at this point, once you've found that, then you say, okay, 1, when my seconds are 1, then my distance is 2. 2 feet for every 1 second. There's your answer. So as long as you have a good grasp and good understanding of number lines and how to place benchmarks on a number line, that is an amazing, great strategy for you to use. I find that I have quite a few students who still struggle with that concept of placing benchmarks on a number line. They can do 1, 2, 3, 4. They can do 2, 4, 6, 8. But then what if we're going by 12 or we're counting by 11? Then students seem to have a harder time sometimes with that. But double number lines are a great strategy. Use them if they make sense to you, okay? I will be showing you 2 ways for all of these problems. Double number line and using our equivalent ratio table. So we have feet per second, right? and we had a ratio of 6 to 3, and we want our seconds to be 1. So now I'm finding an equivalent ratio. Well, how do I get from 3 to 1? Any number divided by itself is 1. I have had very few students this week that can tell me that. Any number divided by itself is 1, okay? So make sure that if you're not practicing math at home, that you start practicing math at home. Those basic facts, not just multiplication, okay? We need to know how to do basic division. 12 divided by 3 is 4. 15 divided by 5 is 3. We've got to know those just automatically, just as we know our multiplication, all right? We need to know this rule, okay? This is going to become very important to you over the next couple of days. Any number divided by itself is 1, all right? 3 divided by 3 is 1. Do the same thing to the other side. Divide by 3. 6 divided by 3 is 2. 2 feet per second. So our rate for the red team is 2 feet per second. All right. And the next slide that we look at, it will talk about why we have changed it to per instead of for every and all of that. All right. So this is our rate. This was our ratio that we were given, and we found a rate. All right. Okay. So a ratio that compares the number of units of one quantity to 1 unit of another quantity is a rate. Notice, units to 1 unit. 2 feet for every 1 second. Every second, all right? That is a rate. You can use the word per, which means for each or for every, to write a rate. In speed, feet per second is a rate that compares distance to time. So we're talking about our speed, right? The red team's robot travels at a rate of, well, we just did that one, right? We said 2 feet per second, all right? Now we're going to take a look at the blue team's robot. Same steps, different problem, okay? We're given a ratio. Blue team's robot travels 12 feet for every 4 seconds. They've put that on a double number line for us, okay? So now that we know 12 feet for every 4 seconds, we want to know every 1 second, all right? So 0 to 4, that's 4 marks. So 4 divided by 4 is 1. So we're counting by ones down here. 0 to 12, 4 marks here as well. 12 divided by 4 is 3, so we're counting by threes. 3, 6, 9, 12, right? Every second. That's every 1 second. If I look at that, then we're talking 3 feet for every 1 second. All right? So that's your strategy using a double number line. You can use a table of equivalent ratios. Feet per second, right? 12 feet for 4 seconds, but we want every 1 second. Now I can find an equivalent ratio, and I do that by looking at how I'm getting from one number to the other, right? So I'm getting 4 to 1. We just said any number divided by itself is equal to 1. So 4 divided by 4 is going to give me 1. If I divide by 4 on that side, I have to do it to the other side. So 12 divided by 4 is 3. 3 feet per second. All right. We just found the rate. The blue team's robot travels at a rate of 3 feet per second. All right. Seems pretty easy, right? Let's apply same steps, different problem. If you would like to try this next one on your own at first, do that, please. Okay. All right. So yellow team's robot is not working properly. It only travels 4 feet for every 12 seconds. Now I will tell you there was a typo here. So this is feet. It should be 4 feet every 12 seconds. All right, because remember, their robot is messed up. So 0 to 4, there's 4 marks, so we're counting by ones. 1, 2, 3, 4, right? 0 to 12, there's 4 marks there, so 12 divided by 4 is 3, so we're counting by threes. So we have a 4 to 12 ratio, and we want to know for every 1 second. 1 is not on my number line, right? It's not a benchmark on my number line. It's there, it's just not marked. So I could put it there, 1, 2, and then we have 3, right? But 1 is right here. How did I get a 1 here? Well, I took this little unit here from 1 to 3, and I divided it into 3 pieces, 1, 2, 3, right? I can do the same up here to this unit. I can divide it into 3 pieces. Well, when I do that, those marks in between 0 and 1 are going to be fractions. So if I have one whole piece and I cut it into 3 pieces, how much is each piece? We would have 1/3 and then 2/3 and then 3/3 would be 1, right? So if I'm at 1 second, then this robot is traveling 1/3 of a foot per second. All right. Again, we can do this with an equivalency table. And in fact, when we get to ones that have fractions like this, it's typically easier for students to do it this way. So 4 feet for every 12 seconds. But we want our rate per second, per 1 second. So we want to look, how do we get from 12 to 1? What was that rule we talked about? Any number divided by itself is going to be 1. So 12 divided by 1. All right. We do the same thing to the other side. 4 divided by 12. Well, 4 divided by 12 is going to be a decimal number. I want to leave it as a fraction. Fractions are division. Fractions are division. If I'm writing 4 divided by 12 as a fraction, I would write it as 4 over 12. Now that can be simplified, right? To 1/3. So 1/3 of a foot per second. Now we're able to answer B here. Does your model show that the yellow team's robot travels more than 1 foot or less than 1 foot in 1 second? So 1/3, is that more or less than a foot? Well, it's less, right? And then it does ask you to explain. So yellow team's rate is 1/3 of a foot per second. Use your model to complete the sentences. In 1 second, the yellow team's robot travels, we just said it, right? 1/3 of a foot. The robot travels at a rate of 1/3 foot per second. So we have units per 1 unit. Every time we have a rate, it's units per 1 unit. Units per second, units per foot, units per mile, all right? So those are rates. D says, the red team, the blue team, and the yellow team race their robots. Which robot will win? Justify your answer. Well, we have rates for each of those, right? What was our rate for the red team? See if I remember. 2 feet per second, right? What about the blue team? I don't know if I remember that one. What was the blue team's rate? I think it was 3 feet per second. Really struggling with remembering that one. Pretty sure that's what it was. All right, and then we have our yellow team still on this page with us, right? 1/3 of a foot per second. So whose robot is traveling faster? well, we can see that the blue team's robot is traveling faster. So the blue team's robot is probably going to win in a race, right? All right. How can division help you write a rate? So think about this. A rate will include a fraction when, what's that problem we just did? Why did we use a fraction instead of actually dividing that out? We said it was going to be a decimal number. So we could take 4 divided by 12 and we could write it as 4/12 and then simplify, right? You can do that anytime you have division like this. If you had 12 divided by 16, that would be 12/16. If you had 16 divided by 12, you could write it as 16/12. Simplify that, right? They're each divisible by 4. So this would be 4, this would be 3. So now we have 4/3. Well, 4/3, I can change that to a mixed number of 1 and 1/3. So we use those fractions in situations like this where we're needing to just simplify. All right. All right. How is a rate related to what you know about writing equivalent ratios? So this is the exit ticket for today. So I would think back to those equivalent ratio tables that we did, right? We've done ratio tables of, red to blue. We had 2 to 3, and we wanted blue to be 6. So we had to find what would make these two ratios equivalent, right? Isn't that what we just did with feet per second? We had 6 feet for every 3 seconds, but we wanted every 1 second. So then we had to find this missing piece to make our two ratios equivalent. So when we find a rate, what are we finding? Well, hopefully we're seeing that we're finding equivalent ratios. All right, we're finding equivalent ratios to make it per unit. For this lesson, I did add on a workbook page. It was page 349, skip number 1. So it's number 2 on the front, and then there were some problems in the back. I want to say through 5. All right. If you have any questions about any of those, please ask. It's more practice with finding rates. You're going to be looking at finding the rate of the cost of turkey per pound, cheese, how much per pound, and then bananas per pound. And the bananas, you will have a fraction. So just work on that as well, and you can turn in the actual workbook page to me at school when I see you. All right. I will see you next time.